factors, when they talk about the glacier movement that they were looking at, you think of factors of things that contribute to it. We've also, in years past in math, we've talked about common factors, greatest common factor. And we're actually going to pull that information forward and use it when it comes to variables as well. So typically we've talked about greatest common factors with numbers. We're going to look at greatest common factors with numbers as well as with variables. Factor. A factor is one of several quantities multiplied to form a product. So what we've been doing so far on this test you just took, you've done distribution, which is multiplication, and you've done foiling, which is multiplication. And now what we're going to do with factoring is we are going to take those products that you are going to be given and you're going to go the other direction. So think of it in elementary school when you learned multiplication and then you learned division. That's what we're doing. We're going to go back the other direction from the products that you would have, and we're going to go back and pull out the common factors. And so the first thing we're going to look at then is, what is the greatest common factor? The greatest common factor of a polynomial is the product of all the factors that are shared by every term in the polynomial. Two terms are considered relatively prime if their greatest common factor is 1. All right, so when you think of numeric factoring, if the only factor that something has is 1 in itself, then it is prime. And so polynomials are considered relatively prime if their greatest common factor is a 1. So let's look at this first example here. Find the greatest common factor. So there's a couple ways to do this. Some of them you're going to immediately see the greatest common factor, and other ones you're not. So if you look at 108 and 72, you may not naturally think of the most common factor. And so what you want to do is you want to use kind of your methods that you've done in the past. We're going to look at then our factor trees. If you break this up into primes, then you will see what primes they have in common. So we're going to do factor trees for each of these. We're going to start with 108. And what I typically do is I do a prime number and divide it out. So if I look at 108, any even number is divisible by 2. So I'm going to start with 2. And I'm going to say, if I were to divide this number with 2 and another number, what would it be? Well, 10 divided by 2 is 5. 8 divided by 2 is 4. And I'm going to go all the way down my factor tree doing that. And I'm going to do another prime. Well, 54 is also divisible by 2. So I'm going to say 2. And then 5 is divisible by 2. It goes in 2 times. And then you have 1 left over. 14 divisible by 2 would be 27. Now my prime that's divisible here would be a 3. Well, 27 divided by 3 is 9. And then, of course, 9 breaks up into 3 and 3. This is how I look at my primes. So these are all the primes that make up 108. If I multiply 2 times 2 times 3 times 3 times 3, I will get 108. All right, that's how that works. There's another way to write that. How would you write that in years past? You would write that using what? Exponents. So I would say, well, I could say that's 2 squared times 3 cubed. That's how we break that guy up into primes. That's how it works for all numbers. Let's look at 72. We're going to do the same thing with 72. If I do 2 goes into 72. That's going to be 36 times. We're going to do this all the way down. And so again, if I multiply 2 times 2 times 2 times 3 times 3, or 2 cubed times 3 squared, then I will get that guy, all right? So then how do I figure out what my greatest common factor is? Well, the most you can take out between those is the lowest of each. For example, if I look at the 2's, I have 2's. 2 is squared here and it's cubed here. Well, I can't take out 3 of them because this guy doesn't have 3 to give me, right? He at most has 2 to give me. So the most 2's that they're going to have in common is 2 of them, all right? Let's look at the 3's. Well, he has 3 3's. He has 2 3's. Well, the most 3's that I can take out then would be 2 because that's as most as either one of them has to give me. So I can take out 2 of those. Does everybody see why I would take out the lowest? Because you can't give more than what you have. All right? He can't give me any more than 2 of those. This one can't give me any more than 2 of those, right? So that's what they have in common. All right? And so then you say, well, what number is this? Well, this is just 4 times 9, or 36. 36 is the greatest common factor. That's how you would do this if we're just looking at numbers, okay? Break it up into primes. If you don't see it immediately, sometimes you're going to see it immediately. If I say, what's the greatest common factor between 5 and 15? You're going to be like, well, clearly that's 5, right? But sometimes when it's larger numbers, you need to break it up into primes and say, what can it give me that they have in common, right? They have 2 in common, 2 in common, 3 in common, 3 in common, right? But they don't have this extra of each in common. And that's how we're going to come up with that. You're going to use the lowest exponent of your common terms, all right? The lowest exponent of your common terms. And then multiply those together, 36. Let's look at the next one. The next one throws in variables. We have 15x and 42x squared. Why? Well, 15 is easy. 15 gives me a 3 and a 5. That's actually all I can do. 3 to the first power, 5 to the first power. If I look at 42, 2 and 21, 3 and 7. So this is going to be 2 times 3 times 7. They only have one thing in common, right? They have a 3 in common, a 3 to the first power to be specific, all right? The 5 is not in common, the 2 is not in common, the 7 is not in common. So of the numbers, they have a 3 in common. Let's look at the variables. This guy has 1x, this guy has 2 x's. What's the most x's that they would have in common? Just 1x, right? Y's. This guy has a y, but the other one doesn't. It is not in common, hence the term common factor. So my greatest common factor between these would be 3x. You are looking for the most things that they have in common. The most things that they have in common. That is your greatest common factor. All right? So to factor, you are going to want to find your greatest common factor, all right? And then you're going to take it out. Think of this process as undistributing, all right? So with distribution, if you had something like 2 times x plus 3, right? You would distribute. You would say 2 times x plus 2 times 3, right? We are now going the other direction. We are given this piece and we want it to look like this. All right, so the way you make it look like that is you find the greatest common factor. For something like 8 and 16, I'm going to assume that you don't need to use your factor tree, right? The greatest common factor between 8 and 16 is going to be 8. So we are going to say, well, list your greatest common factor out here, and then you're going to have parentheses with what is left over inside. What you're doing on the inside is you are dividing. 8 divided by 8. That's going to just be a 1x squared minus 16 divided by 8. That's going to be 2. All right? That is factored form. You can check it by distributing. If you distribute, you should get what you started with. All right? So this would be my factored form. This would be the answer if it tells you to factor. You look for the greatest common factor and you divide it out. All right? So look at the rules for factoring at the top of page 405. Find the greatest common factor of all the terms. All right? It has to be a common factor between every term. Divide it out. You are basically doing the reverse of the distributive property. Write the factorization as a GCF times the sum of the quotients. Check your solution by multiplying the factors. So let's look at this one. If you don't know the common factor between 42 and 14, again, you can use your factor tree. 42 is going to be 2 and 21, 3 and 7. If I look at 14, I have 2 and 7. What do they have in common? Well, they have a 2 in common. So that's going to be one of them. They have a 7 in common. That's going to be the other one. The greatest common factor here is 14. All right? So part of my GCF is going to be 14. I am also going to look at my variables. Between the variables, this one can give me 3 A's. This one can give me 1. So what's the most I can actually take out? 1. So 14A is my greatest common factor. And then I am going to divide. All right, so let's look at the 42. 42 divided by 14. By the way, if you did your factor tree, it's whatever is left over here in your factor tree that they did not have in common. All right, so a 3 was what was left. So that is what happens when you divide 42 by 14. You get 3. All right, my A's. I had 3 A's to give. I took out 1. How many A's do I have left? 2. You are applying, by the way, your rules of division. A cubed divided by A, you subtract your exponents, 3 minus 1. But you can look at it like I had 3 A's, I took 1 A out, I'm left with 2 A's, all right? 14 divided by 14 is what? 1. I had 1 A, I took 1 A out. How many A's do I have left? Yeah, I don't have any A's left. So when I factor that out, my factoring looks like this. 14A is my GCF on the outside. And on the inside, I have 3A squared plus 1. That is my answer. 14A times the quantity is what you're going to hear when you hear that multiplication, the grouping. That is your answer for factoring. Terms. Trinomial is exactly the same, except we're no longer looking at 2, we're looking at 3. So when I look at this, I am going to look at the numbers first. What's the greatest common factor between 36, 9, and 27? 9 goes into all of them, right? 9 goes into 36, 9 goes into 9, and 9 goes into 27. So of the numbers, my GCF starts with a 9. What about the x's? I have an x squared, an x, and an x. How many x's can I take out of all 3 of those?
1.
At most 1, so we're going to say 1. I have a y cubed, and a y. What can I take out?
1.
A y to the first power. And now I'm going to see what's left over on the inside. 36 divided by 9 gives me what? 4. I had 2 x's, I took 1 out. How many x's do I have? Do I have any y's? I had 1, I took 1 out. No y's for this group. 9 divided by 9 is what? 1. You don't have to write the 1 if a variable is left, but you're welcome to write the 1. I had 1x, I took out 1x. How many x's do I have left in there? None. I had 3 y's, I took out 1. How many y's are going to be with this 1? 2 of them, y squared. Minus, follow the signs that are in there. 27 divided by 9 is 3. I had 1x, I took 1 out. No x's are left. I had 1y, I took a y out. No y's are left. That is my factoring. Little part above this example. Not all polynomials can be factored. All right. If no common factor is found, the polynomial is considered prime. It's just like numbers. If the numbers have only one in common, then they're considered prime numbers. All right. So if you can't take anything out, then these are considered prime. So if you look at 51, 51 factors to 3 and 17. That's about all the factoring you can do there. This one factors to 2 and 13. They have absolutely nothing in common there. All right. If you look at the variables, this one has an x cubed. This one has a y. They have no variables in common either. So when this one, if you were asked to factor it, you would just say, this one is prime. That would be your answer if you were told to factor that. That is prime. It cannot be factored. All right. So let's try some of these. Factor. If the polynomial will not factor, write prime. If it will factor, take out the common factor and leave your grouping. So it is possible for polynomials to have groups in common, all right? So you're going to actually use a technique called grouping later in this chapter, and this is what it looks like when you get to this point. And so when you look at, is there anything in common, you can look for numbers, you can look for variables, and you can look for groups. So if I were to look at this particular one, clearly we have a group in common. This part of it has the group x plus 1 in common, and this part has the group x plus 1 in common. And so if I were to say, well, what do they have in common? What's their common factor? Their common factor is actually x plus 1. And so if I were to factor this, I would write out the common factor. Well, the common factor here is x plus 1. And then I'm going to do my grouping after that. I'm going to say, okay. Now, what is left over if I take out the common factor? Well, if I look at this one and I have taken this out, what I have left over is simply the x. And if I look at this group right here and I take the x plus 1 out, what I have left over is the 2. You must put the plus or minus in front of the 2. All right, if that had been a minus 2 in the x plus 1, you would put minus 2 here. Since it is a plus 2, you would make sure to put a plus 2 here. So if I were to factor this, this is what my factoring would look like. X plus 1 is the group that I have in common, and what I have left over is the x plus 2. And so my final answer here would be x plus 1, x plus 2. All right, which is what we're going to get to when we start factoring trinomials. I also want to say this here because this will come into play when we do factoring of trinomials. This answer is the same exact thing as this answer right here. Okay? The reason for that is if I were to give you a multiplication problem and I would say 2 times 3, you would clearly know that that is the same thing as 3 times 2. We are multiplying in between these groups. So order does not matter for the group themselves. It does matter that you have a plus 8 and a minus 2 there. It does matter that the groups are the same, that we have an x plus 8, that we have an x minus 2. But the order in which you list the groups actually does not matter because it's multiplication. And this will come into play as we start factoring trinomials because some of you will factor one way and the other, and you'll come up with the same answer, but it'll just be in a different order. It's all multiplication, so it doesn't matter which order you list it in, all right? I just want you to see that part when we get to trinomials next section. Your common group is the x minus 2. So you're going to take out the x minus 2, and you're going to give me what you have left over. You have an x and a plus 8. So you're going to group that x and plus 8.